everyone, welcome back to another Math 9 video. Today we are doing 1.4, defining a power. And I'm just going to start off with a quick definition. So if we have something like x to the power of m, we know that this bottom part here would be our base. And we know that this part here, actually I should do it in blue, is going to be our exponent. So some of this is going to feel like review because I believe you did this last year. And together the entire thing we would call the power. Okay, so in order to get into some examples, let's take a look at something like 2 to the power of 4. 2 to the power of 4 is the same thing as saying 2 times 2 times 2 times 2. So that happens 4 times. And we don't want to sit there and write out 2 times 2 times 2 times 2 because that gets annoying and that's long. And so that's why we've come up with this power using a base and an exponent, basically to take a shortcut. So again, I'll keep repeating this, but math is all about shortcuts. So this is equal to 16. So there's our first example of what exponents are and what powers are and all of that. So then we have something like 5 to the power of x equals 125. So I'm going to move this up so we can focus in just on this one. If I know 5 to the power of x is equal to 125, well, I want to figure out what x is. So I'm thinking in my head 5 to the power of what would give me 125? Well, I know that 125 could also be written as, I'm going to rewrite it here, 5 times 5 is 25, times 5 again is 125. So I can say this, 5 to the x is the same thing as 5 times 5 times 5. So 5 to the x is the same thing as 5 to the power of 3. So then if I look at it this way, if the base is the same, then that must mean that x is equal to 3. X must be equal to 3. And we can use that idea to help us to solve this question. Okay, so I'm going to go through yet another example. So this time, let's say I have negative 5 to the power of 3. And there's a lot of little subtle details with this. So notice that the negative sign is in front of 5 to the power of 3. So this is like saying in my answer that I have a negative in front, and I'm just going to like leave it off to the side, and I'm going to do 5 times 5 times 5, because that's what 5 to the 3 means. So what I end up getting after doing that is negative, because that negative sign is still there. 5 times 5 is 5, times 5 again is 125. So I want to sort of compare that to another, well, I want to compare it to something like this. If I have negative 2 in brackets all to the power of 4. Notice the subtle difference between the last example and this one. The last example didn't have brackets around the negative. This time the negative is in the brackets, so my base is not 2. My base is negative 2. So this is actually saying negative 2 times negative 2 times negative 2 times negative 2. So if we think our way through this, well, if I have an even number up here, and I have a negative in the brackets, I know that my answer is going to be positive and the negative is going to cancel out. That is always the case when I have a even number up top. So then I go through 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So after all of that, I would get that it's equal to positive 16. Okay, let's compare that with negative 2 to the power of 4. So I want to, well, I'm going to get rid of those arrows for a minute so you can sort of compare and contrast those two. So I want you to start by asking yourself, like, what is the base? In the last example, the base was negative 2. In this example, the base is 2. So I leave the negative off to the side. That's going to be a part of my answer. And then I think to myself, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this time my answer is negative 16 because the negative sign was not in brackets. It's not a part of the base, so the exponent of 4 is not being applied to it. It's like I move it off to the side and I deal with the 2 to the 4 separately. So I hope that that helps you to get a better understanding of the subtle difference between these two examples. And then let's go through one that I'm quite certain you already know. Let's say we have in brackets negative 1 and it's to the power of 100. Well, what is negative 1 to the power of 2, for example? It would just be 1. If I have a even number up here, I know that the negative that's inside here is going to be gone. And I know 1 to the power of anything is simply equal to 1, so my answer for that would simply be 1. Let's compare that to negative 1 to the power of 99. I've purposely chosen large exponents so you can see that when we have a base of 1, that's like a gift because we don't actually have to do anything. We know it's always equal to 1. Okay, but what about when our base is negative 1 and we have an odd exponent at the top? I know my answer in that case will be negative. And negative 1 to the power of anything is just 1. So notice the difference between this last example and this one that I just did. Again, it's quite subtle. And then we're even going to compare it to this. If I have negative 1 to the 100, but there's no brackets there. If there's no brackets there, the negative is not a part of the power. It's not the base. So I know that my answer is going to be negative. And then I know 1 to the power of anything is just 1. So I would get negative 1 as an answer. Let's compare that. If I had negative 1 to the 99, well, again, there's no bracket, so I know the answer is negative, and 1 to the power of anything is still 1. So this time, because of the lack of brackets, these two end up giving us exactly the same value. Okay, now let's take a look at negative exponents. If we have something like 3 to the power of negative 2, we don't really like to have negative exponents. So if we ever do have negative exponents, we want to get rid of them. So it's important that we recognize that this is the same thing as taking the reciprocal of the base, and then the exponent just becomes a positive number. So it's 1 over 3 to the 2. And in this case, we can actually find the answer to that. So 3 squared is just 9. So our answer would be 3 to the negative 2 is the same thing as 1 over 9. Okay, If, for example, we had something like this, mn to the negative 3, that would be the same thing as saying, well, the m just stays there, but the n to the negative 3, I can make it positive by taking the reciprocal just of this part. So the reciprocal of n would be 1 over n, so that moves my n to the bottom. And then the negative 3 becomes positive 3. So mn to the negative 3 is the same thing as m over n to the power of positive 3. Okay, let's do negative 2 to the power of negative 3. Let's think our way through this. It's always a good idea to start by asking yourself, what is the base in this question? The base is negative 2. If I want a positive exponent, I need to take the reciprocal of the base. So it's 1 over negative 2. And that just makes this 3 up top positive. Also, this was in brackets. And then I want to think my way through this. I can simplify this. Whenever I can simplify it, if there's a small exponent, then please do so. But if it was something like 2 to the power of 16, we would just leave it that way. So 2 times 2 is 4, times 2 is 8. So this is actually 1 over negative 8. I knew it was negative because I have a negative in the base, and the exponent is an odd number. So that's how I know that it's going to be negative. Okay, and then here's another nice, quick, easy one. If we have, it doesn't matter, any large number, doesn't even matter what it is, I just made up a number, to the power of 0. I think you know this from before, but anything to the power of 0 is simply equal to 1. So it doesn't even matter how big I make this base. It could be 5 to the power of 0. The answer is still going to be equal to 1. So it's helpful to remember that. And similarly, if we have something like, well, let's take the same number and let's make it to the power of 1. Well, it's just the same number. So it would just be 52,435. And I just realized you probably can't see that. So there we go. In fact, let's fix this and let's move it over here. And that should make it a little bit better. Okay, so I hope that you found that helpful. In this section, I'd like for you to do 1 to 14, only the odd letters. So just a reminder, that just means you want to do A, then C, then E, then G, and skip. And if this is way too much work, feel free to reduce it and even just do A and C for each of the questions. So see how you feel about it and make your decision accordingly.